Ever pondered about the mysteries of our universe? Could all planets just be different stages of Earth's evolution? Our solar system, home to 8 unique planets, each one a world unto itself. Yet, what if we told you that each of these planets could just be Earth, but at different stages of its evolution? A bold concept, isn't it? Picture this. Mercury, the nearest planet to the Sun, could be the infant version of Earth, fresh and raw. As we move further away, each planet represents a different chapter in Earth's life story, culminating with Neptune, the great-grandfather version of Earth. Now, you might be thinking, hold on a second, that contradicts everything we know from conventional physics. And you'd be right. Conventional physics, as we understand it, would deem this concept impossible. The laws that govern our universe, the rules of cause and effect, the passage of time, they all stand in the way of this fascinating idea. However, let's not forget that our understanding of the universe and its workings is constantly evolving. There was a time when the Earth was believed to be flat, when the Sun was thought to revolve around the Earth. Each time, we've had to revise our understanding of the cosmos as new discoveries were made. So what if we're standing on the brink of another such leap in understanding? What if our knowledge of physics is not complete? What if the rules we've taken for granted are just a part of a bigger, more complex picture? That's where quantum physics comes in. Quantum physics, a field that delves into the realm of the very small, where particles like electrons and protons play by rules that seem to defy logic and common sense. In this realm, conventional physics break down and a new set of rules take over. But what if our understanding of physics is not complete? Let's delve into the realm of quantum physics. As we embark on this journey, we'll explore the strange and wonderful world of quantum physics and see how it might just hold the key to understanding our universe in ways we never thought possible. Quantum physics, a field where conventional rules break down. Here, even a single atom can perplex us. Think about it. An atom, the most basic unit of matter, is composed of a nucleus with electrons and protons, whirling around it in a dance so intricate it boggles the mind. But here's where things get truly bizarre. These electrons, these infinitesimal particles that make up the universe, they pop in and out of existence. Yes, you heard it right. They appear, they disappear, and then they reappear again. It's like they're playing a cosmic game of hide and seek. But that's not all. These electrons, they don't just exist in one place. No, they can exist thousands of times over, all at the same time. It's as if they are everywhere and nowhere, all at once. It's a concept so strange, so counterintuitive, that it defies our everyday understanding of reality. But in the realm of quantum physics, this is the norm. This is the rule, not the exception. Now you might ask, how is this possible? Well, scientists believe that it's all down to gravity, or rather, the lack of it. You see, at the subatomic level, gravity doesn't have much of a say. Its influence is so weak, so negligible, that it's practically non-existent. And without gravity to tether these electrons to a specific location, they are free to exist in multiple places at once. But what does this all mean? Well, it means that our understanding of the universe, of reality itself, is constantly evolving, constantly changing. It means that we are always learning, always discovering new and exciting things about the world around us. And it means that in the grand scheme of things, we are just beginning to scratch the surface of the vast and mysterious cosmos. So, what does this have to do with our solar system? Well, the answer might surprise you. Brace yourselves, for we are about to embark on a journey into the heart of the cosmos. A journey that will take us from the smallest atom to the grandest galaxy, and everything in between. Our solar system, a cosmic display of a nucleus surrounded by orbiting elements. Sound familiar? Indeed it should. This celestial dance mirrors the atomic world, where a nucleus is orbited by electrons. Much like the Sun, a nucleus serves as the central point around which smaller particles revolve, in our case the planets. An intriguing parallel, wouldn't you say? Now let's delve deeper into this atomic analogy. Picture an electron. It's known to exhibit a peculiar trait, a quirk of quantum physics, its ability to exist in multiple places at once. This phenomenon leaves scientists scratching their heads, but could it provide insight into our own cosmic neighborhood? Consider our planets. Could they, like their subatomic counterparts, be manifesting in multiple states simultaneously? This might sound ludicrous given our understanding of gravity and its hold on celestial bodies. However, when we consider the sheer vastness of space, the influence of gravity becomes almost negligible. This isn't as far-fetched as it seems. After all, we're already aware that the rules of conventional physics break down in the quantum realm. Observations that seem impossible or paradoxical in our everyday world become the norm. So, who's to say our planets aren't indulging in a bit of quantum strangeness themselves? Throughout nature we spot these repeating patterns, these echoes of structure and behavior that resonate from the microscopic to the cosmic. A tree's branches mirror its roots, a river network echoes a lightning bolt, and our solar system, well, it bears an uncanny resemblance to an atom. This leads us back to an ancient maxim, one that encapsulates this concept of recursive patterns in nature, as above, so below. This phrase suggests that the microcosm and the macrocosm are reflections of each other, that the patterns we observe on one scale are reproduced on another. So, could our solar system be a cosmic echo of an atom participating in the same quantum ballet? It's a tantalizing thought, one that challenges our understanding and invites us to view the universe from a fresh perspective. This brings us to an ancient phrase, as above, so below. As above, so below, a phrase that might hold the key to this cosmic puzzle. This ancient concept suggests that the microcosm mirrors the macrocosm and vice versa. We see this principle in action in nature, where patterns repeat on different scales, from the spirals of galaxies to the structure of DNA. But could it also apply to the very nature of our universe and its connection to the quantum realm? Consider the scripture in the book of Matthew, which tells us that heaven can be found within a mustard seed. Could this be a metaphorical hint to the idea that the vastness of the universe could be reflected within the tiniest particles? Could our universe be a grand-scale reenactment of what happens in the subatomic world, a new perspective on who we are, where we came from, and where we could be heading? Stay tuned for more insight into our universe.